part two here. Now that I've actually got a part, the last thing I have saved this as my part name, I'll just go into the file iProperties and just say what it is so it'll populate my parts list, right? So I'm just going to go at least into the description and say that it's 3/8 plate. I can say 3/8 mild steel plate. It's maybe a little better. So that's 3/8 MS plate. Okay. So now I'm just going to take a quick preview here. It's just 2.5 inch diameter pipe. Okay. And I'll probably shoot for schedule 40, just because it doesn't tell me. And so I'm just kind of using that standard. What I do need is a relationship where that meets, it doesn't, I need these two to slip together. And kind of, I feel like my engineer's done a little bit of work because he's given me some specific pipe sizes. So maybe they've already kind of figured out. But what I'll have to really be careful of is that the OD of this one slips into the ID of this one. So my pipe selection for the 2.5 inch OD, like what scheduled is, doesn't really matter because I know that the 2.5 inch pipe is going to have, no matter how thick it is, it's probably going to have a real consistent OD. According to those charts, you notice that the ODs were always consistent. The IDs change based on schedule. So I'm not super worried about what the ID size of this is because nothing has to slip into it. But this one I'm going to be worried about a little bit. So I'll say it's 2.5 inch standard pipe. And so let's go before I even uh, go to I might pull up some sizes for that. So it's 2.5 inch pipe. So I'll go back into my pipe schedule chart, take another snip shot here. So here's 2.5 inch pipe, OD pipe, which actually measures 2.875. It actually measures 2 7/8 OD diameter. And then my schedule 40 has a wall thickness of 0.203. So that's what I could offset to make, the IDOD on a schedule 40. And so let's do that. I'll take one more snapshot of here. In fact, I'll kind of strategically grab the 3 inch one too, because the one that this one has to slip into is 3 inch. So it's kind of like I'm building like a tolerance fit, but I'm kind of being sloppy. Like a pipe support isn't the most like critical piece of equipment for sure. But so I'm going to take this quick little new snapshot here of 2.5 and 3 inch off this chart here. And I'm going to go draw this with these at least first two dimensions in mind. 2 7/8 and 0.203 wall thickness. So now I've got something to work with here. Let's go ahead and open this up. A new one, I guess. And I can just make a standard part on this. Piece of pipe is what it is. And go ahead and say create. I'm going to derive in, which is up in here. It's a little bit more buried on the 3D, but I'm going to derive in that saddle part. So looking for my 2026 saddle, open that up. And I'll just bring it in as it also obviously shows what it's derived from coming in, but I'm going to also make it just a surface part and say okay. It's kind of a part within a part within a part here now. I'm still on the pipe support. This is my third. No, my saddle's done. Last thing I did was just name the material 3/8 mild steel plate in the description on the iProperties. That's the last thing I did. And now I've jumped to a new part where I've derived it in here. So now it's in here. And I can kind of work from it. So here's my front view still. So my pipe really is drawn this way and down. So I think I will just pick I'm going to pick a plane to draw this on. Um, and maybe I'll establish a plane. So we haven't done this too much either, but like I'm only given these preloaded origin planes, right? Which are great to have. I've got 3 planes that I can draw a lot on. In this case, maybe if I just think of where my part lives here, it just comes off here and goes up, right? Or it goes down, but it's just going to butt into that. So I can actually establish like a sketch plane that would be like tangent to that curvature there. And 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 that might work pretty good. I could also draw it, I could draw that pipe profile because I think what I'm going to do is I'm going to draw it as like this ID and OD circle like I did with that first pipe and then just extrude it how long I need it. I mean, if I started that sketch here, I'd be extruding through and then I'd be cutting it off where it goes through the saddle. So I think what I'm going to do is these planes right here. So if I just say go over on the 3D model tab to this plane section right here, this is you can draw. So this is just establishing kind of a work plane of your own. And so a lot of designs have like a lot of different like you as a drafter designer can put a plane wherever you want a plane, and you can use all these like preloaded planes, kind of the ways they will establish a plane for you. So maybe I just want one that's um yeah, maybe just I'm thinking of one that just lives kind of like straight, like on the essentially kind of parallel with this plane, but actually tangent to that outside curvature surface. So let me see if I've got that as an option here. I definitely have offset from plane. So I could use this one because I could measure how far that offset is from that one plane to my curved surface. So I could definitely use this one. Parallel to plane through point. I think there's one that's tangent. There's tangent to surface through edge, tangent to surface through point, tangent to surface and parallel to plane is I think the one I want to choose because it's going to be tangent to my curved surface and then it's going to be parallel to that other plane. So let me see if I choose that. Tangent to surface and parallel to plane. Sometimes when you're choosing these are where watch your command line because it might walk you through the order of operations of selections. So if I choose this, it says select curved surface or planar face. So I'm thinking I need my curved surface like this. Then it says, maybe that's it, or maybe I need to actually choose the next one that I'm parallel to. Maybe this one. I think you can choose either one first because the command line really didn't change. I think I could have chose the plane to be parallel to first and the curved surface to be tangent to, but it should just be these two selections. And then it drops that in there automatically. And planes like look like this is kind of the underside of a plane. It goes slightly greenish, and top side is what's that? Oh yeah, I know. That's kind of it's there's like you as a drafter and designer, you will explore all of these like depending on your geometry that you're working with. Like I have used quite a few of these in my career just to establish a working plane. I just chose to use this one because I'm looking for a tangent and a parallel kind of relationship on a working plane. And I'm saying, oh, okay, here's the curve. So I've picked that one, tangent to that curved surface, and then parallel to this plane is the next selection. And that's why it establishes this plane here, which is really kind of where I think of my parts like from here down. The interesting thing is it really goes a little bit above that too, because this shows you if you just cut a piece of pipe square, just kind of in a chop saw and cut it off square, like you kind of buy your materials and they're square cut on the ends. If I were to butt that in here, it would look like it would have these big old gaps on the side, right? So what we're going to end up needing to do is yes, maybe I can now have a place to draw my pipe and extrude it from this plane down, but I might need to extrude it up a little bit in this direction to where it intersects my saddle, and then I can use the saddle OD to like cut my pipe and cope it to match that contour. That's my plan here. So you can extrude to a face too. Yeah. And so I think there's some different options we can look, whether I put in a dimensional or just say extrude to that face. Yeah, yeah. To the face in that direction and to a specific length the other direction potentially. Yeah. So what I'm going to do is I don't know how long to extrude it, but I can kind of look at my jump back over here to my assignment and get an idea of how long this extrusion is if I can look at the sketch again. Like they don't give me a good, maybe they don't give me a crazy good length here. I don't know. I guess I'm kind of 8.5 inches tall, and then I need to be able to get, if this is 8.5 inches tall, then what's the difference from there to there? I think I'm going to say I'm gonna target the 19 inches tall, and then plan on this part being definitely a hard length, right? This is going to be 8-inch pipe here. This is going to be 8-inch length of 3-inch pipe, I should say, and then a 1/2 inch. So that's going to be a fixed dimension, 8.5 to there. This is my variable. What they mean by here is that, and this would be pretty common in telescoping parts. There's maybe a minimum distance that this can be. Like I wouldn't want this to pull out any further than 3 inches and potentially become kind of like not structurally supported well enough. Like for whatever reason, we've determined that 3 inch of like overlap is the minimum. I can have more than that, so this thing can drop in from there. But I don't want this thing to ever pull out to hit a height that decreases this minimum relationship here. And it's probably for stability and probably, the more you pull that out, the less stable that part is. Even if I weld around it, you just don't have like those just those pipes like fitting together. I mean, the more they intersect telescope into each other, maybe even the more stable they are. If it's like 6 inches in there, you get a part that really can't tip easy. But anyway, so it's something to watch. Like they want me to not be any less than 3 inches when this thing hits the 19-inch overall height that it can hit. So this thing's got to hit 19 inches and it has to maintain 3 inches of overlap. What controls that whole relationship is the length of this part that I'm making. So if I think just a little bit, I'll think to make my part from here down. And I need to kind of consider how far is this? Well, this was a 10 and a half, a 10 and 3/4 radius, 10 and 3/4 diameter. So whatever that is divided by 2 is how far it is to here. And then I have a 3/8 plate. So I can kind of figure out what this measurement would be because it would be a fixed measurement as well. From center of pipe to my bottom of saddle is going to be what I say is like 10 and 3/4 divided by 2 because I'm looking at a radius of the pipe here. So really what I have is a 5 and 3/8 from center of pipe to my saddle. And then I have a 3/8 plate thickness. So I can say here plus 0.375. So really I kind of have fixed dimensions here, 8.5. And then I have a fixed dimension here to there as 5 and 3/4. And so what's the difference after I take those two off? I don't know. And I'm thinking of the longest height, 19 inches. So I'm saying that because what I'm able to figure out, that would be the dimension from here to here. And then I just have to add the 3 inches to my part. So what I'm kind of looking for is to figure out what is this dimension. And so I say that I need to know this 5 and 3/4 and this 8.5. So I'm going to add 8.5 to it plus 8.5. And my fixed dimensions already kind of tell me that they're at 14.25. So I don't even know if I can ever get down to 14 necessarily. I can get down to 14.25 if this thing like collapses. If I slam that thing all the way down to the top of here, I technically can't get as low as 14. I can get 14.25. Maybe that's close enough. Probably in a pipe support it is. Other things, 1/4 inch off is way far off. So depending on the application, if this is sufficient or not. But just based off my parts, my fixed parts, I can't ever collapse less than 14.25. But now I'm just going to take the difference of that from 19. So I just showed it as a negative value, but it's like that means from here, this little point here on my drawing to here is got to be 4 and 3/4 plus the 3 inches. This gets confusing, right? This is the way my head thinks. If your head thinks different, to get to this, what I'm looking for is just how do I know how long to extrude this thing so that I maintain 3 inch minimum telescoping and hit 19 inches of adjustability? Well, I think I need to have 4 and 3/4 there plus my 3 inches. So I've determined that this length from here to here is 4 and 3/4. So I might just enter that in my calculator and come back to it. Clear this thing out here. 4 and 3/4 is how far I at least need to extrude from my working plane down, right? Plus 3 inches, of course. So what I'm going to do is go onto this plane and do a sketch. So I'm just going to say, let's sketch on this plane. New sketch. Wants me to draw on the top of the plane, but I can draw on the bottom of the plane as well. I really want to lock into this, and this center point here is going to be where I'm going to drive these diameters. So if I refer to my little screenshot again, 2.5 inch pipe is 2 and 7/8 diameter, and then I'm going to offset at 0.203 to make the wall thickness. So I say I got a circle for the OD of 2.5 inch pipe. It's actually 2.875. And I'm not entering. 2.875. Excellent. And then I'm going to offset that. The wall thickness for schedule 40, which is it 0.203? Yeah, 0.203. Yes, 3. So there's wall thickness. And that's the pipe that I need to extrude to support this saddle. This is maybe the most complicated part to make, I think. Is this little part that we're making right now. Just because of the dimensional figuring plus kind of figuring out how to meet this curvature. But I'm going to say finish that sketch. And I'm going to go into my extrude now. And this is my profile that I want to extrude. And I do want it to go both ways. But how can I program this to be what I want? Well, I could say maybe two and then two next. I don't know. If I choose that, will it give me that option? Definitely I can choose this if I say two, and you'll see that's how much of a little cope it has in it. And then I need to go to the next distance. I don't know if I'll have that. It's going to that surface. If I go both directions, I don't think it totally gives, I don't know. I'd have to play around. This one right here, right? Asymmetrical over my center. That's definitely how I would have to go to do this. Let's see if it gives me. Yeah, I think maybe distance A. I can say two next or two surface, right? Like there. And then it switches back. So it doesn't love that
You just hit the plus sign.
the other way from the same sketch, right?
Same profile, yeah.
Yeah, yeah. So that's what this is for, is to add like multiple, apply a new extrusion from the same sketch, which is the same difference of me as like doing one and then like returning on the sketch and then using that again to do the other one, right? And then joining those solids. So you can do that within and do two different directions right here. Because this is the first one I'm going to do. If I just like, yeah, I think I'm going to say to the surface is what I chose, and that's what actually drove this direction. It needs to go this way that far. And then if you add a new one, so it's got that one in there. It's kind of like it's done, and it's like keeping the sketch open for you to say, and then this profile, I need it to go maybe the other direction. How far? Well, that's what my 4.75 is. But really it's 4.75 plus 3 inches that have my minimum going into. So whether you do that as one dimension, call it 7.75, or I've done mine as kind of a double dimension where I get my actual fixed dimension plus my minimum. Yeah. And then they will stay joined. You know, there is two different solids going on here technically, but the only way you would make them two different solids, you know, the extrusion going one way and the extrusion going the other way, is if you selected this plus. That would make those two independent solids. I don't want to do that. Default, I think, is always to join these, but there are reasons why I would need to make a new solid. And that's the other way that I'll show you, given time, even if I don't show you till Thursday, how I would do this again. I think it's value added in um, showing how to do multiple parts within one part. But okay, so I think this is it. This is like how I need that to be. It's got a cope to it. Fits my saddle nicely. That's going to be a welded joint. I think it's a 3/16 fillet all the way around on that. Those two are going to weld together. Probably in the shop first. Yep, just slap that thing over there. But this would be really hard to make this can become really like these copes are really important because for a fitter or for a welder to do that, a square cut one would be far less. I mean, you'd have to fill this gap here, and that it can be minimal on some parts, but it can be really extreme in other parts. And so, you know, having these coped pipe, which how do they do that in? Well, there are actually like Premiere has a freaking machine that can you can put pipe in and it will do these kind of cuts actually. Just it's amazing. But not all companies have those. They're really expensive. And so other companies might have a sander, like a belt sander. They can actually take this pipe in and bring it in like nice and horizontal. And the belt sander kind of runs like I don't know if you guys have ran belt sanders. They kind of have like the belt just comes around kind of an end roll. But they can take out the end rolls of those belt sanders to different diameters. And so you can kind of get like people can actually hand sand a coat pattern in. The other thing I can do is I can make a piece of paper. I can make a part that has like almost like zero thickness and wrap around this thing and create a coat pattern and deliver them like a one-to-one printed coat pattern. They could like wrap around their pipe, maybe spray paint it or mark it however, and then put that little coat in. So there's a lot of different ways this little part can be made manually by hand or, you know, expensive machinery if the company has it. But that's all I really need to do there. So this plane, yeah, this is it. I just need to say that this is also mild steel. So I'll say steel mild. And then I'll call it 2.5 inch schedule 40 pipe is what I'm going to call it in its I properties. So I'm going to say it's just two and a half you can sometimes see people put like a dash between their wholes and fractions. I don't know what different companies have different ways of separating like inches and decimal inches or something. But here's 2.5 inch. I'm gonna call it SCH. That's schedule. I think there's maybe there's, I think I just put SCH. If I did schedule acronym, what is it? I think there's several different. Sorry. Just want to see what I don't know what our books would cause it. SCHED, SKD. What does our little chart call it? I don't know if they actually say in their little column. SCH, I think, is what I've used, but I could be wrong. Sorry, I'm slightly interested in this. What does this say? Do they have an abbreviation for their schedule? No, they have the full schedules written out. SCH is what I'll put in mine. Right or wrong. Schedule 40 pipe is what it is. 2.5 inch, schedule 40. And I could maybe put MS as a mild steel pipe. And generally I'll be probably typing in a company standard potentially. And then I can just turn these off. So I can turn off the part I derived from and the work plane that I used to establish my sketch, and then just save this part as my, I think I just called it my pipe upper. Pipe upper. I have a 2026 version. Okay. You're building this relationship though. Any changes you would do to one are going to impact some of these others. We might flex that and see if we could go to a 12 or 8 inch pipe or something and see how well this like impacts. One more part though. I'm going to derive this thing in to the other one. So, and this is another critical relationship that this would work right. This is going to slip into the other part. So I'm gonna create a new standard part. I'll derive in that one. New standard part. I'm going to derive in my pipe upper from this year. I'll just put it as a skin as well, or a surface. There it is. What's that? Yeah, it's right here on your 3D model tab, derive component. So that's how I bring that in, right? And then I didn't choose any real, the only thing I chose is to bring in surfaces like I've done on the other two. Yep. And I'm just going to do a sketch right on the end here. So this, well, let's see here. Yeah, I think I'm going to sketch the end here because this part, well, let me think about how this might go. I'm kind of building this, if you can tell, I'm kind of building this in the, let me go back out to the next, I should have closed it over there. Let's see here. I'm kind of building it in the relationship they're going to be to each other once they hit an assembly. And it's going to make the assembly really fast, but I don't always do this with all parts, but I think I'm going to, from the end here of my part, I think I'm just going to like offset a plane 3 inches from there. And I'm going to build this thing kind of from there down. What I want to do is build my part so that it kind of lives in this relationship, that it's already overlapped 3 inches from that on that derived part. And there isn't a plane there where this one kind of starts, if I think of that. So I'm going to establish a plane there. So I'm going to just kind of the same way, only it's a little different way of establishing a plane. I'm going to say, here's my part. I know it's all kind of goofy and curved up there, so I'm kind of working from this nice square end of it, kind of strategically a little bit. Because I'm going to say, oh, put me a plane. I'm going to offset from plane. And so I think when I choose this one, this is another working plane. It just says select a plane or face. Well, I'm gonna offset it from here. And then it just says, okay, what's your offset distance to establish this working plane? And if I say, well, it's 3 inches, well, it's actually going in that direction, but this is where you use negative values to drive it the other way. So there's -3 inches. That's the wrong way though, isn't it? No, that's correct. That's correct. Essentially, this one's going to be inside the other one, like 3 inches here. And the top, and my part is going to start here, and then I'm just going to extrude it down at the dimensions of a 3 inch pipe. So I'm going to say okay on this. This is just establishing a working plane for where my part lives. Those are editable though. Like this plane has, since I've set those parameters, this plane, shows up here. If you go to edit this, edit the dimension is where you would go into to get back into that plane and maybe drive it differently. So it's all editable. I don't have to get it right the first time. I just have to know how to get back into those menus. And this one is just right there, edit dimension. anytime you do a working plane, you generally have parameters that you're setting, and then they're adjustable or modifiable. So that one's a 3 inch away plane. And then I just need to like refer to my 3 inch pipe schedule chart, which I took a snapshot of. So 3 inch pipe that they're asking for on the lower pipe is 3.5 inch OD diameter. And at a schedule 40, it has a wall thickness of 0.216. That's great. I'm going to draw it like that. And then I'm going to stop and evaluate and say, once I get that diameter of the ID, does it fit my 2 inch and my 2.5 inch pipe? Because they have to work together. And it might be that I have to get creative and order a different wall schedule thickness in one of them. However, if I do that, I have to know that I'm supporting the right load and I'm not minimizing how much this pipe support can hold by dropping away from a standard pipe. Um, and maybe creating a part that would have to be machined or whatever. I think the way the engineer delivered this to us is we're trying to source stuff that's just on the shelf. And so we're not trying to make this, if you think of a pipe support as just it's not a highly accurate piece of a part, but it does need to function good. And I'm trying to source something that just will work together without a bunch of machining work that would increase the cost of this part. If I can just buy a couple pieces of pipe, chop them, cope them, they fit together, they're weldable, even though the gaps might be a little bit bigger. For this application, it could be just what we need. So, and it would be faster and cheaper than machining a part for a pipe support. Although some pipe supports get pretty critical and they do get machined, and there are some reasons, but I think I'm trying to go simple here, the KISS method here. So I'm going to draw a 216 wall thickness on a 3.5 inch. So those will be my offsets. So from this, I'm going to work from this plane right here. It's kind of the bottom side of it, but that's okay. I'm just going to say sketch here, new sketch. It might flip my part around a little bit here, so I just need to identify, oh yeah, here's I'm extruding this way down. I can cut to that plane, F7 slice graphics, right? So there I am on my plane. And then I offset it 3 inches from the square bottom edge because I ended up having to do a -3 just based off, yeah, how it was establishing my plane. Yours might be a positive value. I think it can vary on your selections. Mine ended up needing to be of negative value, but yeah, I established a plane from the bottom of this 3 inches up here. This is a critical dimension. I'm trying to maintain that here. So I'm actually kind of already building that into my part before I even start drawing it. I'm already building where it lives. Since I've derived in that other part to work from, I'm kind of go ahead and establishing a plane that isn't exactly where those two parts come together. So yeah, that's where my plane is now right here. And I'm just going to draw the diameters for this 3 inch pipe here with that offset. So I'm on that plane. I need a diameter here. So 3 inch pipe, I'm going to snap it to the center grid. So it's going to be constrained is 3.5 inches on a 3 inch pipe OD. So that's how wide that is. I'll just choose schedule 40 here. So here's what I can kind of keep track of. I can actually project in this geometry. This is the outside geometry. I may have to select like something like this to project the outside diameter there. I mean, that's what's got to fit inside my part. And now I'm going to establish a wall thickness and make sure I don't jam into that or make sure it's not uh, too much of a gap. But on a standard piece of pipe, 3 inch standard, 40, schedule 40. The 40S, I think that's stainless pipe. To have an S on the end, I do think that's a designation of stainless, which shows you that mild steel to stainless, they actually are holding the same wall thicknesses and diameters. That's different on sheet metal, but some of the same materials fall under the same sizing here in pipe. Or different materials fall in the same sizing. So I'm looking at an offset of 0.216. Let's see how that works. I'm just offsetting this diameter for what actually 3 inch schedule 40 would be, 0.216 wall thickness. And so this shows that, oh yeah, that one slips into that one really easy. In fact, it looks like it has a lot of gap, right? It is a welded joint. So I do need to kind of consider, is that too much or not enough? I don't know. Like, what is that measurement? It's the difference of whatever this diameter is. 2.875 to whatever this diameter is. 216, but what is the actual diameter? 30680. So I kind of want to know how much like gap this is in between. So let me figure what that is. This is the outside. So I'm just kind of, they definitely don't, I mean, this definitely works. They would slip into each other, but will it be too sloppy? I don't know. 3.0680. So this is 3.0680, right? Oh, sorry. We've got some function going on here. Is it 88 or 68? I think it's a 6. And then I'm going to subtract from it the 2.875, which is the OD of the upper pipe. So really I have this much gap, but really that's not all the way around. That's the total gap. That's if I pushed that over to one side hard and I would have this much gap on the other side. So if I divide this in two, this shows me what my gap really is, kind of all the way around. So really these two fit together, but they have a .09 clearance, which is, not a tenth, but getting close to 1/10, which is less than an eighth, but we have a little bit less than an eighth of an inch gap all the way around. That could be too extreme. I mean, the only way I can make that smaller is to source a different piece of pipe that's a little bit thicker here. So, I mean, I can look at that and see what it would be. And it's kind of interesting for me to know that if I look at this chart and I say, well, I can buy 3-inch pipe in schedule 40 and it's this wall thickness. The next option I would have, which is a big jump, is schedule 80. So it's essentially double the wall thickness. It doesn't look like double the wall thickness, but the schedule has doubled up to schedule 80 and the wall thickness will be 0.3. So let me look at what that would be. All I do is while I'm in here in my sketch, I would say change this to a 0.3 if I get schedule 80. And then now what kind of a gap do I have? Well, there's a gap there. That's still I still have a gap. I still don't have it, but how close is this? I don't know. I need to see my diameters here, right? And that chart probably gives me my diameter, but I can just look at it. It's 0.29, and this one is the same. It's like point or 2.875. So it's really a difference of 2.9 now. So I might do a little check here. 2.9 on the inside diameter of schedule 80 3-inch pipe. And then if I subtract 2.875, I really have only 25 thousandths. But then I need to divide that in by 2 so I can see what's all the way around clearance. And really I'd have like 12.5 thousandths. It's probably a pretty good fit. Like this is way less than an eighth of an inch. This is only 0.01, 0.0625. It's pretty tight though. So this is only 12.5 thousandths. The other problem is pipe sometimes comes with an inner seam that there's like some weld junk or some crap in there, the way they weld pipe together. And it can be formed different. You can get seamless pipe that's way more expensive, or you can get this like welded seamed pipe that kind of has stuff in it. So if I buy this, I'm afraid that I may have to make someone like ream out the inside of this 3-inch pipe in order to fit the 2.5-inch pipe inside it. So that could be bad. So this would be a good conversation to have at this point. It's that I've evaluated my options, what we can source, because Schedule 80 and Schedule 40 are probably on the shelf. Those are two really common wall schedules to have on hand. Maybe 2.5-inch pipe's a little bit odd, but I don't think so. 2.5 and 3-inch pipe, really normal size pipe. So I feel like I probably can source both of these, and this is a good conversation to have. I could even go on the rack out if we're building our own equipment, I could go look at the 3-inch pipe and be like, does it have a big old ugly seam inside of it? And if it does, I might be like, if I go to a little bit, if I just use schedule 40, you'll have a sloppier weld fit, but you'll definitely probably have to do less grinding on the inside of one potentially. So these are things you have to think about, but you have to know your materials as well. And so this is a good conversation to have with an engineer. Should I use schedule 80 for this one or schedule 40 with a big gap? And they might be like, oh, let's just use schedule 40. And because we know there's going to be a little grinding potentially anyway. An 1/8-inch gap, it's pretty easy for them to fill. You might need to know they're going to weld this with shielded metal arc welding. So they're going to be stick welding this out in the field. Oh, yeah, they'll be able to just grab and fill that up. And they would rather it slip together easy than have to fight a fit out there in the field. You just have to have those conversations and wonder, before you make an ultimate decision, especially where you're a designer and then your design can kind of affect that if you don't. So I think this is just going to be a little bit tight. I like it. It's clearance. But I think I'm going to go for the sloppy fit. And it's just based off me knowing that my pipe stand is probably not super critical. an 1/8 inch or a 0.09 gap all the way around. I'm thinking I can weld that. It's almost like a good root opening. So I can get plenty of, I might make me have to take two passes around that, like one root and then one fill. And that could be slow us down a little bit. But so I'm going to go back to the 0.216 was the schedule 40 wall thickness with a kind of a bigger gap. But so I'm going to say finish that. And that is my, so I'm saying I'm using schedule 40. It's easy to change it though. Like this is just the sketch I would come into. It's only going to affect the ID of that. And it would affect my description. And I'm upside down and backwards there. I don't know, somewhere here. There it is. And now we're going to extrude this thing. This is a fixed dimension though. If I look at my sketch, it's really a fixed dimension. It's 8-inch long piece of pipe. That's staying fixed here. So 8-inch is all I got to extrude this in one direction, kind of down from the coped end. Yeah. So let's say extrude that thing 8 inches. That's kind of how it's going to be. I'm going to say okay, and then change that to steel pipe. Mild steel. And I'll go ahead and update the description with what I currently am picking. So I'll update my project file and my description to say that it's 3-inch. Schedule 40 is what I ended up choosing. Mild steel. I mean, you could put pipe. Did I put pipe in the? I don't think I did. Sometimes pipe is left off. If I see 3 schedule 40, I'll know what that is. If I see that description, MS mild steel. So you could put pipe in there if you want to, if you can't remember. If you know, this definitely doesn't make sense to everyone if you haven't worked with a bunch of pipe and you're. I do. I've been capitalizing everything that I can, kind of like our general standard is, be yelling at everyone always. Yeah, just capital letters. I think my name is coming across and this is okay. So, some of my stuff is mixed fonts, but that's it. This thing is done, right? I'm going to turn off my work plane, turn off my derived solid surfaces, and just save this thing as a lower pipe. I think I've got it in my there's my pipe lower from 2026. And now we just need to build a base plate for it to sit on. So I'll probably finish up. I don't know. We'll see. I'll get to some drawing stuff. You can see my drawings. I've uploaded where I'm headed. I won't worry about that yet. I'll keep talking about assembly. But I definitely, before we all leave and get the assembly all put together, I just got to build a piece of plate here. So I will do that. Another new home. I think I'll make this a sheet metal part, and it's 1/2 inch plate, so I'll have to set up a new like sheet metal default. But let's do that. So that's kind of handy. It's like here's my sheet metal. It doesn't have any bending or rolling, but it still is a piece of plate that's going to be lasered or plasmid. So it's going to have just like a 2D cut file is what I think of. That's the whole point of that saddle piece and making a flat pattern is it makes your drawing be just a 2D drawing to cut that. And they'll load the correct thickness of material to get their 3D. Same thing with this base plate. It's just 1/2 inch plate, even though it has no bending or rolling or whatever. I'll be able to cut the holes in it and it'll be a cut file that will be for so I will still make a flat pattern for it, in fact. So even though it is already flat. So I'll make a sheet metal part, create it. So that's my pre-planning a little bit. I'll go into my sheet metal defaults. Really common to have to like pick your default first because you always usually have a thickness in mind when you're doing this. I don't know if mine are going to come up again. And this, I think, yeah, that's interesting. Even mine isn't reading that I had the 3/8 part already built. So that one that we built only lives within that part. I think I'd have to go out and like program where this is pulling from and set that up. So I'll just make a new one in this one and I'll say it's a 1/2 inch. 1/2 inch. Do we say plate or something? I didn't really specify type. I just said 1/2 inch plate. Okay. So on 1/2 inch plate, the thickness is 0.5 because that's the thickness of the plate. And really this, I guess I can set the material type here is S for stainless. I mean for mild steel. So 1/2 inch mild steel, that's the only thing I'm really programming here. And I'll just say, yep, save it and close. And then I should be able to pick that from here, 1/2 inch plate. And there's my thickness showing up, correct thickness. It's going to bend by these rules that are already pre-programmed. Okay. So now I'm driving, and now I just want to, I'm still going to derive in that piece of pipe because I'm just going to build it in relationship to that piece of pipe. So I'm going to say derive in my lower plate, lower pipe, I mean, the lower pipe from this year, this one. And I'll just bring it into surfaces again. Okay. Yeah. Yeah, you'll see your other derived ones on if you have them open in your other. Yeah. Me, I'm turning those off before I ever leave, just so when they come in, they look like this. But yeah, it definitely has this there is a cascading like one part off a part off a part. So and you can always go into like from here, you can open that base component, is what we'd call it. Like that derived part, you can open it from the one that you've derived it into, and it's just like open base component, or you can even edit the derived part. Well, that goes back into that menu when you first place it, but you can open the base component from here and make modifications, and then it'll affect this side of things. So upstream, downstream relationships here pretty heavily here. I mean, these are all dependent on each other. So then I just need to know like which one is up and down because I'm going to draw this plate on the correct side. So this might help that I know that here's my front view. I've been building everything to my front view. So this is technically the bottom of my part. This would be the top of this part here. So I'm gonna put a sketch plane right there on that base. There isn't one from the origin or anything. In fact, the origin for this is going to be like way up there where the pipe was, way up there. So really, I'm just going to build a plane. And I think, can I just hit plane and then just hit a surface? I think so. The most basic one would be just to put a plane there like that. Is that correct? Maybe I've got to actually like set it here with no offset. I was thinking this plane, does this establish a plane? Define working plane by highlighting and selecting geometry. And I think that's the way I do it. I was thinking that first one allows me to do, but maybe not. Maybe this is like not one. This is an offset plane, but with zero offset. So I can check that and there's a plane, zero offset. And then I'm just going to sketch on that plane. So let's do a new sketch. And maybe I'll just like, slice my graphics. So there it is. This one's going to be just a rectangle, right? Some holes in it. So I'm just going to draw the rectangle shape. What is it? 8 by 8, right? Is that correct? Let's take a look. Square, 8-inch square base plate, 8 by 8, with a 6-inch square kind of hole pattern. So I could use that too. Yeah, let's do this. I'll say that this is 8 by 8. I'm not really drawing, I'm not constraining it yet. I'm just drawing the size, 8 tab 8, like I would in CAD kind of. And I'm just going to do my normal horizontal and vertical constraints because I want it to be centered over this origin point. So however you want to do that, I like to do this kind of stuff this way, where I pick a midpoint. You've seen me do this a lot. There's my midpoint, horizontal, constrained to that. It doesn't push those points together, it just keeps them in horizontal alignment. Same with this vertical one on this midpoint. So this is the way I'm centering it over my part, which is how if I slice my graphics, that's how I want my part to sit there, right? And I'll extrude this down a 1/2 inch thick. I'll F7 slice those away though. And then maybe I'll just draw another rectangle that is constrained also, but this is 6 by 6, 6 tab 6, because this is the hole pattern. The holes will be in the corners of this, so I can use this geometry to create this where the holes will live here. And if I just hit enter on this and then do my same kind of like horizontal constraints to midpoint, you could have offset that though too. You could have done an offset to the outer circle, offset an inch all the way around would have built that too. This to me, I'm just using as a reference. So I'm going to turn this to construction geometry. But what this kind of has, these lines have endpoints right here. These can work for the whole command. The whole command just needs it needs a point placed, like a point, but when you have lines that intersect at a point, you don't need to place another point on top of this. These will function just fine. And maybe I think some of you have already been using that, and that's great. If you can use this geometry to use your whole command on the actual 3D model tab when you come out of the sketch, you could also choose to, now that you have these easy, you could plop the centers of circles here too, and have those holes incorporated into the sketch. And so either way is fine with me. It doesn't matter what I mean is like I can place one circle on these points, and these are 13/16ths, which you can type in 13/16ths, or you can memorize that that's what is it, 0.8125? Yeah. What's think it's 8125 for a 13/16, right? Because I kind of remembered that off my top of my head that the hole is 13/16 for the bolts that are 3/4 inch. That makes kind of a 30-second difference. I mean, it's a 16th inch difference, but it's really a 30 seconds of clearance all the way around. This is a pretty sloppy clearance, even only being a 30-second all the way around. Um, but that's pretty good. You would just definitely, this is definitely not, I mean, it is critical that you don't get these too big and oversized. I've seen them go, I think our company said an eighth of an inch over, which gave you like a 16th of an inch all the way around. That was kind of our company. That was Idaho Steel Products. And we did a lot of floor anchoring. Like if you think of equipment in a food processing plant, all of the legs for equipment get like anchored down to concrete floors just to hold equipment in place, keep it safe, keep it sturdy and stable. So a lot of equipment in plants has foot pads like this. This is if you enter the drafting world in mechanical drafting, you'll build like foot pad plates for everything. So everything in the world gets anchored down to the thin crust of the earth that will not hold up to an earthquake in a lot of cases, sometimes. But anyway, so I think we would shoot for an eighth of an inch over on all of our like hole. I just remember that. So I feel like they're just a little tight here, but it's still clearance. That's the critical thing. There's clearance here. And so I like it. I'll keep it 13/16 and I'll say I can make copies of this, but you could have done this with the point command. It's either or. I'm just going to go ahead and do mine. I'm just going to make a copy of these. Or we could pattern this, right? You can do a rectangular pattern here, but I think I'll just do a copy of this by its base point. Sorry, that was me selecting the base point and that. Let me select base point there, there. I only do this if these things are constrained though, and they don't look like it looks like it messed up all my constraints until I maybe go to flex it. But the funny thing is, they don't always like they are kind of constrained. It's weird. Like if you ever do this with copy, you'll be like, well, why? How is this not constrained? I like snapped it on there, but I might have to do a coincident constraint, which is kind of annoying in a sketch a little bit. So if you do the whole that, I think it's just that it knows it made a copy of that, but it like didn't snap its center line. So sometimes this is kind of annoying. I just want it to be there. And so patterning it wouldn't have had this kind of an issue, but I like to show maybe different it seems like you can't move it. You try to flex it and it can't flex. But I'm just looking to like say, I just want to constrain these two together. So I'm just doing a coincident constraint from the center to like the center. And that's all that's holding that in. These might be independent. This is the other. If you do this kind of work, if you make copies like this, it makes a copy of the dimension, but it's like you can turn these back into just by driven by that. So this additionally has other work on it that I'm like, oh, maybe you don't want to do it this way. And it's easier with the whole command. And I can show that, but I'm just showing you that I'm just kind of like at least driving these so that there's just one dimension. This is the main one that will drive all of those. Even if those ones have been selected by this, it's like a function of a function. Yeah, I don't always have to pick the main driver. It'll still change. But yeah, this is a little bit like you can choose like I don't like this way. Well, it's fine. Yeah, you learn that. You could have patterned that, it would have been easier. You could have just done it as a whole. But I'm going to do this as a face now. So a face is going to do what extrude does, but I've already programmed my thickness. So face of this thing is like extrude. And in fact, it's going the direction I want it to go, which is away from my pipe. And to use the whole command, you would have extruded it all as that square and then come back. And I'll just say okay on this, but you would come back and like choose. So you choose the whole command, which is kind of buried in the sheet metal layout tab. But over here, it's the same. Whole on those corners of those, even all I needed was that rectangular or that one construction square to pick those. You could have picked whole, you could have picked multiple points, the ends of those, set one parameter, cut it through. So if that's easier for you, that's good. Either way is good to me. This just needs to be, oh, it's mild steel, it's polished. This is a done part, right? I just use face because I was when you use face, it's going to extrude to the sheet metal default that you set. So in order for that to work, I had to make sure I set my default first. So I had my right thickness. And now anything that use face is just going to be that thickness as a default. So Yeah, it's just that's generally the order of operations. When you're making a sheet metal part, you probably already know the size of sheet metal that you're wanting to use, and so you would probably set its parameters and the defaults. Then go ahead and mostly instead of extrude, I use face, but that's why you guys had to remind me that there is still extrude. This is it. So what the last thing I'm gonna do though is I'm gonna create a flat pattern. So I'll go ahead and define an A side. That'd be the top side. This is gonna sit against probably some concrete or a footing of sorts, just gonna mount down to something. So I'm gonna say the A side is up, even though it's just a piece of plate. It's probably not that critical, but since I have that option, I'm gonna define it. There's my A side. And then a flat pattern is right there. It's created. It doesn't have any bending or anything, but I still have a flat pattern. This is kind of my DXF file type essentially that I can export to CAD. I'll go back to my folded. So now I have it in two, and then I'll just turn off this other stuff that I used and then turn this off and save that thing. I haven't got a name yet, but this is just should be base plate or something. Base plate is what I call it. Yep, base plate. Pretty common term. 2026. Okay, save it. Okay, well, I got all these parts. I don't need this one in my assembly. It was just to derive from, so I'll turn it off or I'll just close it. And then I've got my four parts, right? Saddle, upper part, lower, and the base plate. Let's start an assembly. I'm just going to do a standard. We're done with weldments probably for the rest of your life, unless anybody ever uses them, but you may use them. We'll see. Yeah, but we only did the weldments because I was just showing you for you to be the welder. This print will not have any welds on it. It'll just show the weld symbols. Yeah. So this will be kind of the normal way you actually do weldments. It's just the welds don't get shown. Yep. Unless there's a real good reason for them. Like a flange bushing, that's a good part. Yeah. It could be a weldment. Yeah. I just wanted to do that because it makes you guys welders, which is what I like. No, I don't actually. You're in the right trade. That's as much welding as I want you to do. No, I'm just kidding. Welding is fun. It's funner if it's a hobby rather than a job. Because welding as a hobby is super good skill. What were you guys asking me some questions? Oh, I didn't update the eye properties. Good call. Let me do that before well, I'll just go ahead and start my standard assembly. I'll create it just so I have it open here. There's my assembly, but I will. Yes, right. Let me update this. Good. Eye properties on this plate should say half inch. Uh, yeah, like half inch mild steel plate or half inch. I probably have this wrong, but I can. Is it MS plate or maybe I said plate MS, but I'll fix those when I see my parts list description. Half inch mild steel plate. Yes. Okay. Yeah. Yeah. Definitely once I get to my drawing and before I make my PDF is where I use because anytime a manipulation that I do here, it's gonna, yeah. Usually I worry about that once I'm just trying to save it as my PDF so that it has the masses when it makes that copy. But yes, what we want to do is build an assembly. And so by the way we've done this, this will be slick and easy. I'm gonna bring in all those parts. So I gotta find all my parts to derive in, which is in my week 6 now, right? In my pipe support parts. So I had my saddle that I built. So I can open that one and place it in there. And then I'll place in my other ones. Saddle, upper pipe.
Do we want to ground and root the saddle or bake?
We're gonna ground and root everything. It's just gonna put it where we want it, just how we built it. That's what we're gonna do. So instead of doing a bunch of constraints, the only problem with that is it definitely like locks down. It's like the maybe the ability to animate it. So this if I'm building an assembly where I do want to do some animations, then I need to control those constraints, right? Because we end up kind of to do animations, we kind of drive the constraints that we build. So this isn't how I would do something for if I knew that that was my output. This is just down and dirty, easy to like. Since I built everything and how it lives with itself, I just ground and root them all and it'll be done for me. So what do I need here? Do I need my lower maybe? Can't remember what if I place yeah, part upper, part lower, and I just need my base plate, right? So do one more place, a base plate. Yeah, so I just have them randomly thrown in here. Yeah, and let's just start that. I'll ground and root all of them individual, or I can probably ground and root them all in the same command, right? So ground components. If I just ground and root all these and say okay, it built it for me. It's pretty slick. Now it's a Lego arm. It reminds me of it's a Lego guy's arm. Ground and root every one, and and the only reason why that works is because they were all built from each other as a derived part. It's a pretty slick way because sometimes we build a lot of parts that we don't necessarily animate. We just need to show them like this. Now I need to evaluate this and make sure that I've hit my dimensions correctly and make sure that I don't need to go in and adjust maybe some of my working planes if I guessed wrong on my lengths. I tried to think about it through and how it was going to end up here. But yeah, these are just all ground and rooted parts built from each other. So that's pretty slick. Now this thing's ready for a drawing.
Already
I can probably get an idea how close I am. Yeah, it's like 19 inches, which should be from like the center here to the bottom here. So I've actually hit 19 inches at its full, at its full length. And I think I can even check here, if I measure this, I don't know if I can actually get in there and measure it without making it invisible, but I built it so there's 3 inches of, minimum overlap here. And I realize that I can only get as low as 14 and a quarter actually when this thing bottoms out all the way down. It's going to hit there, I think anyway. I mean, I could actually animate that and drive it down as low as it goes. But let's do a drawing. So I'm just going to open my inch template that I've had an update with last week, right? But I've got it saved here. Inventor inch, open it up. I'll go ahead and save this. Oh, wait, save it as new location where I'm keeping my drawings for today. Week 4, week 6. Pipe support. I've got a drawing folder here. I just called it pipe support assembly 1. I'm going to do a 2026 dash on mine, but just pipe support assembly. Save. Sometimes I put my drawings over here and my assembly over here. I didn't save my assembly yet, so I probably need to save that. Maybe give it a name. I can just name it pipe support. So I'll go into its iProperties real quick and just say pipe support. I could say it's a 10-inch pipe support. That'd be kind of handy to see the description that says 10. I think this will accept inches like that. I don't know, 10-inch pipe supports. It could be, I might not need to put the inches because but kind of, or I could say inch. 10-inch pipe support. Okay. My other feeling of this was the reason why I kind of built it this way is I'm thinking I should be able to go into my piece of pipe and change it to 12-inch. And everything will kind of the way I've probably sketched my stuff and projected my geometry, I think my part should change to accept a 12-inch with just one probably change on the pipe. I'm gonna try that uh just for my own I'm gonna kind of do this little flex, which you don't have to. You could save this now. I didn't save my assembly yet, but I need to save it as yes, I'm gonna save it. I think I have a pipe support here. Pipe support 1 is what I called it. But maybe I will actually put the 10-inch in front of this, like a 10-inch. 10-inch. Yeah, maybe I'll do a lowercase, something like this. 10-inch. Yeah, whatever it takes. 10-inch pipe support, something that you can recognize it. Okay, save. And now I can put this on I'll just take a look at that and then I'll put that as my base view. There's front base view with a view label. I think I chose to kind of show what he showed because it was enough information to draw, right? It's like I need a top view and probably um, definitely a parts identification isometric view. So I'll drop those two. I think I ended up putting a section view on mine, right? Because I think I sectioned mine so I could see that the relationship of these two together specifically, so I could call out that. Let me take a look at my drawings on the scroll down here. But what this is pretty. This is kind of I don't think I'm going to change anything. I think I'm going to draw this essentially the same way. I kind of have this like section view where I'm cutting through those clearly, and just so I can mostly call out this relationship of how much gap I have all the way around. So looks like I'm dimensioning definitely kind of overalls of this plate and maybe an overall of what that looks like. Maybe that it's centered. Just kind of some rough dimension. I do have quite a few assembly. I got all my weld symbols on here. Got a weld all the way around in the field. 3/16 fillets, arrow sides, all a 1/4 inch fillet here though. I'm definitely showing that I'm 19 inches modeled, but I'm adjustable down to 14 1/4. Well, I'll just leave it there. Got my parts list here. Then my so this is yeah, and I show just some general overalls plus I call out some general notes here that I'm matching 10 1/4 inch ID pipe. And then I come down here and this is where I'm breaking out each part individually, right? So I have my parts. So I have a few different, like I might have to go over some of this, but it's just I have a few different dimensions I can pull. This is called an arc length dimension. So it's kind of the flat pattern dimension slightly, but it's kind of a reference dimension because I'm saying that it's probably not accurate. I'm just giving it as kind of a rough. We need about 12 inches of material to make this. Looks like I'm using 2 decimal places on everything. I'm kind of calling out what this is coped to of a radius. Got them clearly labeled. Yep, I've got their masses updated, it looked like, before I saved my PDF. Believe it or not, that's 22 pounds. I'll have to see how much. It is a lot of steel. 1/2 inch plate, 3/8 plate. They're heavy plates. They definitely are heavy. And then I've got the one last sheet is my cut file sheet. So this is why, I name what do I have in assembly pipe support? It could say ASSY, pipe support assembly, pipe support parts. And this could say pipe support cut file or something, but here's the cut file. These are my 2 flat patterns that I created that I'll place on there. And I have my bending notation, which one of them has a rolling bend, but rolling. Like I said, they'll either press break it or they'll roll it. That'll be their choice, probably, unless I specify from an engineering or design standpoint. Press breaking leaves kind of creases in it, and rolling it will be smooth. But rolling 3/8 plate. Not all companies have heavy enough rolls to do that if they're just sheet metal shop. But 8x8, this just helps somebody quickly identify. And I don't even put on any center marks here at all. Really, I just want that one, like the bending and rolling center lines to show up. Other than that, it's just a real simple. I can make a DXF file of just this sheet to send my nester. So generally, we would print our cut file sheets for all of our general fabricators, so they could, and then we would also make a separate DXF PDF or drawing. Usually, it was a DXF, in a DWG file for CAD that the nesters would grab. So what we would do is we'd save all of our files in their folders, and then as we release the jobs, and once the jobs get released, they're usually there was like an in-house email that we'd send, like send to production, job released. They would just go access that folder, pull out their PDFs, because they started to go to a paperless shop essentially, just so they were using screens to view prints and stuff. They would just access the folder once you told them the job was done. And then in that folder, we had our drawings so they could see everything. And then they would have a DXF folder maybe for the DXF files that the nesters would go in and pull. So I think I've told you, somebody wrote a macro that would pull they would pull in cut flat patterns as DXF files. So that's a pretty sweet macro that somebody built. All I do is click a button and say create flat pattern or create cut files. And essentially what it was doing was just turning my flat patterns into DXF files. And they would kind of bundle them in a zipped folder that the nesters would go in and grab. And all it was DXF files. They didn't get all the print packs. They didn't care. They just needed to nest parts to cut. So that was a pretty slick macro. I don't know. Somebody wrote it from Boise actually, and they were smart. I don't know if I can recreate it. I don't know what they did, but it was slick. So I'm going to build this thing, but you can see where I'm headed. Yep. But I can I think I'll probably end my video here. I might pick up a few. It looks like I'm a little bit. I probably should use all caps. I told you all caps. I just wanted the inch, and then I'll probably change that to all caps. But I think I got to scale this down a little bit, don't I? A little bit too big. That's a quarter scale. What I end up putting on mine. You went a fifth scale? Yeah, that would probably work too. 1/5, 1/4. Oh, in mine, you can see my scale is like a 1 to 5.
I think so that you're.
Has changed, huh? To where this, yeah, this one can be dropped down a little bit lower if I need to.
How do we get the cut files?
Oh yeah, let's see here. I should have made copies of my sheet. I do this every time. I always forget until I start putting stuff on there. I'll change both of my scales to 1/5. Yeah, and I don't want this view label on actually. That's kind of not common to have my isometric view label on. Let's see here, my cut file. So I'm gonna make a copy of my sheets here. So I'll make my copies now on my browser tab. I'll just say copy this, come down here, click into no man's land and say paste. And I'm gonna paste a couple sheets. Like I said, sometimes I paste extra sheets so I can I should have done one copy and then clean it up because now I've got copies with all this stuff on them and I need those deleted. Delete them. Yes. So my other sheets won't be that. This one won't be that. I just always forget to make my copies of my sheets before I put stuff on them. There, now I've got 4 blank sheets. Yeah, and then I'm just going to yeah, so I can place all my views here. I know I've got to come back in here and start detailing this first sheet that's called B size. To change that name, I'm still changing it here just because it allows me to have different name sheets rather than just drive in like the drawing number name. So I like to change my names here still, like edit this sheet as pipe support. And I could say it's a 10-inch 10-inch there's maybe my sheet name, 10-inch pipe support assembly. My next one's going to be like, I'll change the name of it while I'm in here doing this. I think it's going to be 10-inch. Something like this, 10-inch pipe support parts. And then my last one was a cut file, and I can name it 10-inch pipe support cut file if I want to. Just I can say 10-inch cut file, whether it's 2 words or one, I usually slam it together and a 10-inch pipe support cut file. And then I've got one extra sheet in case I need more sheets there that's blank. So I can delete that at the end if I don't need it. But yeah, so like the last thing I might do here is just before I start dimensioning and sectioning and stuff, I will just place my parts list real quick because it's going to be my assembly, right? My 10-inch pipe support assembly. I don't want the parts list. I want the assembly parts list. Let it activate it. Yes, maybe I'll just pop it up here next to the revision tab here. I can move it around later. I can shorten it up a little bit. Yeah, 3/8 MS plate, 1/2 inch MS plate. Oh, that's good. I like my descriptions here. Individual part numbers, quantities are called out, items. I'll balloon those things and come back to it. I mean to do that. There we go. Keep it small like that. So I'm just ready to balloon that, dimension that thing out, take one section view. Maybe I'll cut I'll cut the section view before I move to the next sheet too, because you know it's a good one to practice here. My place my views section. So I should be coming into this view. I want to take a section view of this view. I just want it to cut in here. So I think I have to cut this way. So I click there. I'm going to draw into about the center line here. Maybe I'll target that, cut into center. And I'm going to cut through here on center, but not click to anything. And then pass through. I don't know if I can target where I started, but that's okay there. If I say continue, I think it's going to wrap too far. So it doesn't, I don't love that. I don't think I need to click that many times. Let me see. I'll work on that one again. Cancel that one. Let me see. Section, this view. Maybe I only have to go like here, through here. Yeah, I think that's all I actually have to do is just I just did it centered across mine, and then I can extend them out a little further. But I'm just wanting to do, yeah, full depth. Okay. Scales a 1.5 or 1 to 5. So let's keep the same scale. So I think I can say okay. Then move this thing over. It's an orthographic projection right now. I think I scaled mine up. These things are now grippable, right? I can pull these over, so move my view label here. Yeah, so all I had to do is just draw a line down for actually this type of section. If you try to draw that, just, yeah, I'm always a trial by error thing saying, oh, that's not the way I want to do it. It's nice to get that on there because they do take up a fair amount of room. And so you'll know that where you want to put your weld symbols. Technically, I could have sectioned the other way too and dropped it over here. So what this is now is by default, they're orthographically aligned. I think I end up moving mine out of alignment just to create some space. Let's see. Yeah, I actually blew it up a little bit bigger, and it's definitely not in orthographic alignment. So just probably because the space I had to work with here. So let's do that a little bit. I definitely want this. It's too small of a detail here, so I'm going to uncheck this because it's scaling from the base or the parent. So if I uncheck this, I can manipulate its scale independently, right? So 1:4 maybe. How big is that? I think I even want to go bigger than that, really. Let's go maybe a 1/3 scale. I don't know what mine calls out. I guess I could look at that, but it's still orthographically aligned. So in that edit the view tab on the I think it's display options. You just got to kind of toggle through these. You don't have much option to change anything on the model there. Here's the align to base, which is always checked by default. The definition in base is where it's picking up whether it's, I think, hidden and solid lines and stuff, which you can break that relationship as well. I think what I have going is fine. I just don't want it to align to base. And if I say okay, this thing now becomes kind of that removed section view concept. As long as I'm labeled good here, I could put this on another sheet if I needed to. But 1:3, what did I think I ended up with mine? Oh, I actually ended up went clear up to a half scale. So sure, I can try that. It's a good detail view. And I don't even need, I can minimize the size by pulling this in a little bit tighter too. Of course, it's really an unconstrained sketch that's actually holding this. I tend to keep these auxiliary and section views and detail views unconstrained, so I can kind of move them as I need to. I really try to avoid having auto constraints pop up when I'm dropping those. Otherwise, they just get harder to break away without getting into the sketch. But it is this sketch here. The sketch is, you can get into it and break those constraints if they happen, or you can delete them and start over. But 1:2 is maybe what I'm thinking now that I saw my drawing. Yeah. And the biggest thing is I just need to tell people what that clearance is, But if I check my own, I did add a center line. Good. Add center lines. These things need center lines, center marks, pull them together. A few dimensions with descriptions. I need to build this though. This is just individual parts. So I'm showing them in their kind of finished form, right? So like this one I'm showing it when it's formed up. Because if there's prefabrication personnel, the ones that throw this on and cut it, then they throw it off on a pallet. Maybe somebody cleans it up and hands it to a prefab personnel that might be running sheet metal rolls and press brakes. And they would want to know this. They would want to know how they have to form that part. And then once they get it formed up, they might throw it back on the pallet and be like, that part's now formed and done. And so they don't need to know this. This is what the welding fabricator technician needs to know. And it could be that somebody else is doing the cutting for them. Somebody else is doing the forming. They're getting issued a pallet of parts to make 100 of these things or something, right? So have a good day, welder. That's why you put your podcast in and put your welding hood down and build 100 of these things throughout your day. And while somebody rolls 100 of these for you. All right. So I will do, so the cut file itself, like that's going to be on sheet 3. Let's do that. So these are just going to be in their standard views, and yeah, we haven't done too many cut file sheets. So I'll jump over to sheet 3 and show you how to place a cut file. So you can either come in here and just place base and pick the one you want to do, which I have all of mine open. So I have all these options. I'm kind of lazy. Sometimes I just like go look at the part. Like here's one that needs a cut file and the base plate needs a cut file. So I'll choose this one first, the one that's the saddle that's already bent. I'll take a look at it. I'll go back to my drawing and if I hit base view on this, it'll be that last one I looked at. So there's mine. Only instead of doing the folded models, because it has a flat pattern, that's only because it has a flat pattern, I can select the flat pattern. And then that view shows up. And you can scale this the same way. Like You might work for a company where it's really critical that all your cut files are at the same scale because the machine it's going to depend on those scales be the same, and really pay attention to that. It's really common for me to whatever parts I put on my every sheet, I have them all at the same scale. Modern equipment, it's less critical. It'll always be cutting the 1-to-1 and it's not factoring in scale. But just so you know, some old equipment, it was really critical that we not have mixed scales on mixed sheets. I can have different scales on different sheets, but it didn't like mixed scales on the same sheet, I should say. And I don't remember why. It's just, yeah, it caused a lot of issues. I still put a title on it so they know what part number it is. And mine's just defaulting a quarter scale. I think that's fine, but it's just that one view is all I really need. So it's got its identifier on the annotate tab, kind of this. Anytime you have like you use a hole with threaded features, this is going to help you just put it's going to automatically apply the correct specific note call out. Same way with bend here. Bend is really for your flat pattern sheets, and so you can tell someone how to form this into what it looks like on the other drawing sheet. So if I put bend, here's the bend, and it says it needs to go down from here because this is my outside part. So this is like upside is what I chose as my A side, which means this thing bends down and away from me because it's kind of put the upside up, the A side up. So and these are movable, like you you can either make your nester move these or sometimes we move them for them like this and just say sometimes some places they don't care. You just drop that note right across the sheet and leave it there. Some places might want you to move it. I think I don't know how I can actually move it like this. Can I keep my profile of my sheet down? I just gripped a grip and drug it like that. And then it was common for us to tell people what the overall dimensions were. And I can use my SME standard. This one should be at 3/8 away, and this one should be at 3/8 away. That first, right there. That conflicts with that, so I've got to decide what's going on here with this piece here. I can cut across that. Maybe it's a little sloppy, or I can drop it down to this side. How about that? Let's just do that. Now I don't have any conflicts with dimensions down there. Kind of compact, just so they can quickly identify with a measuring tape what that part is. This could look like a lot of different parts, so it's nice to be able to. And I think I told you before, laser operators will sometimes pull your view label, drop it on there, and then like scale it down and have that etch that part number on it. That's really common with lasers. As long as as long as it's not in a nuclear reactor and has some weird laser cut etch on it that causes some like collection of atoms or something, and then I don't know what it would do, but there's high control parts that you can't just etch where you want to and cut them how you want to. And yeah. Okay. That's flat pattern. The other one I have a flat pattern for, and so it doesn't need any other views of the flat pattern. It just needs that profile that's going to cut. That's all that's critical on a flat pattern. And then, and of course, it's critical that I make this a DXF file, this one sheet. For us, just go ahead and just do it as a 3-sheet IAM file is fine. IAM or IDW file. But I need my base plate on that sheet as well. So I'm just going to take a look at it, jump over here, place the base view. I'll keep it the same scale. It's quarter scale. And then I just want it to be the flat pattern, which already orientates it like this. And then I just need that one view with its view label. Yeah, so it's just like if I go in and place that base view, as long as you have a flat pattern, if you don't have a flat pattern, if you haven't created one, this is a good indicator when you go to set it on a cut file sheet where you're like, oh crap, it'll be grayed out, but it's right here. You just select it. So you have to have created it within the part, right? It won't automatically create one for you. You'll have to go back to the part. I say define an A side, then choose flat pattern, and with a view label, yes. So then you're going to get your dimension tool out here, and this one only just really needs some overall dimensions, so I can identify that this is 8-inch. If you want to be lazy, you can, and on the text panel, you have option. I don't show like in the dimension panel, right? You have these three tabs where you can totally change dimensioning and really you can establish a new dimension style kind of manually here for one dimension. But on here they have a bunch of symbols that you can use, and one of them is square, right? Right here, square. That placed it behind my dimension. If I would have moved my cursor in front of it, which is for a square symbol, I'd probably put it in front like this. So if you ever see this symbol, this just means it's 8-inch square. So it's just a square symbol. But it's kind of lazy, but slick, slick and quick. It's 8-inch square. And that's all they would need on that. Yeah, that one has no bending, but it needs to have a cut file, you know. If it makes you feel better, you can check some of this, make sure it's the right dimensioning. But you'll see that when you go to detail out your sheet, because this is sheet 3. I need to go to sheet 2 and place those parts, and it looks like I used it looks like I just used like a front and a top view, front and a top view. And these ones are probably, I probably spun these around to show this as kind of a front and side view. This would be pretty common. I'm not calling out, interestingly enough, you can see how simple my dimensioning is here because really this is 2.5-inch schedule 40. So that's controlling all the dimensions. Like you might work for somewhere where they're like, go ahead and pop that dimension on there so I can see it. And but for me, what's controlling that is just having that description. I can identify that. Maybe I'd have to go to a chart to see the sizes like I had to do, but that's so I don't know. It's up to, and if I did that, I'd put a diameter symbol and dimension it here. So it wouldn't be wrong. It's like helpful information, especially for you guys. You probably don't know. I mean, even I don't have memorized what 2.5-inch OD is or whatever, but so I'm keeping pretty simple dimensions there, that it's 2.5-inch pipe cut. This just shows actually the other thing you have in prefab a lot is people cutting saws, blanking off saw cut items. So these prefab people are cutting laser parts, plasma parts, rolling, press breaking, and sometimes just saw cutting parts to blank lengths. So, and then they might even be doing the cope on them if they have a coping machine set up. So there's other kind of coping machines. They almost look like a side mount end mill, like a machinist tool, but they're just made for coping pipe, and they have it's an end mill that would go into a machine, kind of like a big drill bit with kind of teeth on the outside of it, a little bit more aggressive looking drill bit, and it's made to side cut, and they can actually run that into the end. And so they make specific machines for coping. That's a lot of companies that would do this, especially if you like a handrail shop. Like handrail shops have the best coping machines probably because handrail is a lot of coping going on with different materials. But yeah, super cool. Yeah, it doesn't look like you could put some like sketch breakup in here too. You can see that I didn't. I feel like I can clearly delineate the views from one another and make sense out of what goes to what. If you want to put some sketch breakups, you can. I generally do that once views maybe start to be confusing on which one goes to which view. But yeah, this is all we need to do to call it a day, you guys. We got the pipe support done. Holy cow! I know you got a bunch of dimensioning to do and but it's pretty much done. We can jump into GD&T on Thursday, talk through some questions, and